So the next thing on non-parametric statistics is to looking at the runs test. Okay, so we went through what runs means, and then we said that runs test is designed for large samples and then small samples. All right, so I think the runs table, I don't really have it available, so it kind of a little bit challenging to be able to look at the runs table, but we'll go through this. And then, so if you have the runs table, make sure you cross check, and then we see what is happening. All right, so when you have small samples, so we're looking at when the sample size are small. So how small is the sample size? What will you use to determine whether your sample sizes are small? All right, so remember that you would have two types of, let's say, data points. Okay, so you have female and male combined, so you want to know how many males there, how many females there. So n1 can be males and then n2 can be females. So if it happens that n1 is less or equal to 10 and n2 is less or equal to 10, then we say that your sample sizes are small. All right, so in that case you go and then use the runs test for small samples. Okay, but if these rules are violated, the sample size are greater than 10, then you would have to go for runs test for large samples. Okay, so the alternative hypothesis, I told you that in any statistical test you would have to state the alternative hypothesis. When the alternative hypothesis are stated, then you can go ahead and then do the test. Otherwise you don't do the test. All right, so what is the null and then the alternative hypothesis? The pattern of sequence of observation is in a sample is randomly generated. So what I always say is that now you are doing something, you have no idea of what is happening, so it's better you saying that it is that. So trying to check whether it is random, so you better saying that okay, yeah, it's random, and then you go against it alternative, yeah, it is not random. All right, so this is just basically saying that the null hypothesis saying that the sequence, the how you generated the male and female is random, or it was randomly generated. How you did that wasn't random for the alternative. Okay, all right, so take note of that. And then the test statistic and then the critical values. So how do you get a test statistic? The test statistic is the number of runs. So it happens that the test statistic is not anything difficult to find. All right, so the first thing you have to do is to state your null hypothesis and then alternative hypothesis, and look for your test statistic. And it happened that for small sample your test statistic is just R, where R is the number of runs. Okay, so the test statistic is just the number of runs. Now that you know the test statistic, you have to find the critical values. Okay, so know the critical values and then you can now take your decisions. And then the critical values are 2. All right, you need your K1 and K2, and this is obtained from the runs test distribution table. All right, for small samples. So this table is given in a, I think this book it wasn't given, so I actually want to find out and then see this book, but I think I'm not seeing that book. So if you think you have the runs test watching this video, kindly give me a scan of that, and then I'll be very, very happy to use that to explain things. All right, so our critical values, we need our K1 and then our K2. Okay, we need our K1 and our K2 before you can make decisions. Okay, so it's what this one means that if your runs are less than K1, okay, if it happens that the number of runs you get is less than the value of K1, it means you are not random. The data point is not random. If it happens that your number of runs is greater than K2, it means you're also not random. Well, what it means is that the K1 is kind of a minimum value. Okay, kind of a minimum value. That is a minimum number of runs, okay, that you get for you to be random. So if you are less than that value, you are not random. And then the maximum number of value, which is K2, that you have to obtain before you be random. Otherwise, when you go above that, you become not random, right? So it better you fall within K1 and K2. So if it happens that your R1 is between K1 and K2, then your data point is random. Then you have to fail to reject H0. Okay, fail to reject what? H0. Okay, all right. So that is that. So this is a rejection rule. If it happens that your R is less or equal to K1, okay, less or equal to K1, reject H0, or is greater or equal to. So if it is within K1 and K2, then you fail to reject H0. So this is a typical example. Okay, so test the randomness for the following. So there is a first data at alpha 0.1. So this data, I have to find out the number of runs. Now no n1. Okay, so n1, remember that per n1 should be less than n2, less or equal to n2. That's very important. Make sure your n1 is less or equal to n2. That is very important. Make sure that. So 1 2 3 4 5, and this is 1 2 3 4 5. So this one, n1 is 5, n1 is 5, and then n2 is also 5. All right, so this one, they are the same. So now how many runs? We have just 1 2. So our critical test statistic, which is t, is just, let's say, is just 2. This is our r is just 2. So we have to find out the K1, right, and the K2, and see that is my 2 less than K1, or my 2 is greater than K2. Then I'll go ahead and reject the null hypothesis, which is saying that these data points are randomly generated, right? So first of all, state the hypothesis. The sequence are randomly generated. The sequence are not randomly generated at alpha, which is 0.10. So the test statistic, we said number of runs, and then it happens that the number of runs are what? 2 for the first one. Okay, and then the second one, 2, you check 1 2 3 4 5 6 7 8 9 10 11. I think 11 runs. This one 1 2 3 4 5 6 7 runs. Okay, so this will be the test statistics for individual each of these ones. All right, so that is basically what you need to be doing, right? So so the first one, which is 2, we have to find K1 and K2. Okay, so if you have the runs table, you have to check, first of all, there is this column which has n1 and n2. You have to check n1 and n2. All right, so you go to 5 5 5 5, and then you try to look for the values. Okay, remember the alpha value was 0.10. So the alpha value was 0.10. Okay, so if you go to the table, you will see this bracket. So you have 5 5. So on the 5 5 column, okay, there are lots of probabilities here on this line, and then on top of that probabilities, there are numbers. Okay, numbers, the number values for k, they will be on top. So what you have to do is that, all right, you divide the alpha into 2 to be 0.05, isn't it? So what you have to do is that you look for that probability on that lane, okay, which will be less than that. Okay, which will be less than 0.05. okay, so you check that probability and trace it up and pick that number. So it happened that at 3 the value was 0.04. okay, 0.04, and then at 9 it was 0.04. Okay, right. So this is another thing that was done. This was done. This was done. So we picked 3 and then 9. So it happened that our 2 was less or equal to 3, so we have to reject each not. Okay, and conclude that the sequence are not randomly generated. Okay, right. So the thing is somehow a little bit difficult without a runs table. So we'll see whether we'll get a runs table, then we'll come back to this video or do another video on that, which will be using a runs table to illustrate that. All right. So this is another one that you will have to use a runs table. Now what if it is the sample size is large? Okay, what if the sample size is large? We'll do that in another video, so watch out.